Okay, so we're looking at a word problem, right? An application. I know everybody's, or some people have a lot of like feelings attached to those, right? But like, it's gonna be okay. We're gonna figure it out. Read through things 2, 3, 4, 5 times, however many things, right? Make sure you understand what's going on, what the thing is asking. A pair of shoes is $70 regularly. Okay, $70. They're on sale for 25% off, and you have a coupon for an additional $10 off. What is the final sale price, and how do you find it? What do we need to do? $70 by 1/4. Why 1/4? Okay, 25%. So Emily, you did the discount part, $70 regular price, on sale for 25% off. Okay, let's figure that part out first. $70 times 1/4, or 70 times, how else can I write 25%? 0.25, yeah, or 25 over 100, right? Percent is of 100, right? So either of those is fine if you don't see the, or if it was like 32% off, like I don't jump to that being a nice fraction. So that's the 25% part. What does that give you? 1750. Okay. Okay, cool. So the shoes are 1750, right? Wait. No. What is that? That's how much it's reduced, right? Okay, so what do they actually cost then? $52.50. Okay. So this is the price after that 25% discount, right? I guess I could have just said sale price. That's the sale price, right? That's anybody walks in off the street can buy for that much. But you, special person, have a coupon for an additional $10 off. So how does that work? Just subtract 10, right? $52.50 minus 10. That's $42.50. This would be what you pay, right? That's our final answer. $42.50. That's hard to see. Sorry. I'll just box it. There you go. That's what you would pay, right? Everybody okay with like mechanically what we did there, how all that works? Okay. You could also, if you wanted, you could do this part by figuring out what 75% of 70 is, right? So if anybody did it that way, that gets you to the same place, right? Okay. Does it matter which order we do those in? Why? What happens if you do it the other way around? You get a different number, right? If we do the coupon first, 70 minus 10 is 60. Then 25% off, we'd be looking at $45, right? Okay, well, that's a different amount. So it must matter what order we like put these things on, right? What order we stack them in. The difference is that here you're doing 25%, well, percentage is, applying to the number on a smaller number. So you're taking less off. That's why you end up paying a little bit more. Okay, so the point is that we've got sort of multiple things happening, right? Where we're sort of applying a couple of different things to it. And also it matters which order we do them in, right? Okay, so this is an example of what we call function composition. A function takes a number, does a thing, spits out another number, right? So what we just did, applying these operations like finding 25% off of the thing, that's a function, right? I'm not writing it down as like an equation. We could, but that's what it is. You're multiplying by something and then subtracting, you know, from the original amount. So that's a function. The coupon, the additional $10 off, that's a function too. It takes a number and subtracts 10 from it. We're doing them one after the other, right? So that's what composition is. It's applying more than one function, kind of one after another like that in a sequence. Everybody have what they want from that stuff? Yeah, okay. So that's function composition. The way that we write that, or the idea, I guess I'll say this: one function followed by another. Like do one after the other, right? I'll talk about the notation real quick. Because this is a new thing, right? It's not like addition, subtraction, multiplication, division, where like we already know what that means, what it does. Because it's a new thing, we introduce a new symbol. This little circle between the F and the G here or there, that's the composition operator. You read that like of. So this G composed with F, or I could read it as G of F. And what that means is the same thing as this. Now, if I write it like that, what we know about function notation already should tell me a little bit about what that does, right? If I know these two functions, G and F, and I want to find G composed with F or G of F, looking at this, what does it look like we should do? And the big idea is that it's going to be one after the other, right? Do one thing, then do the other thing. Which one should come first? Okay, so start with X, your input, right? Okay, so I'm going to write it in terms of X, or if this was a 2 or something, I'm going to use 2 in place of X or whatever, right? So that does its normal thing, right? That's our input or independent variable. Then what? Should we do F first or G? F, why? It's in a set of parentheses, right? So normal order of operation stuff still tells me how to do this. Start inside parentheses. Okay, well, there's my input thing. Cool, I've done that set of parentheses. Then I should do F first. It does whatever it does. And then that becomes the, cover this up, whatever is here is the input, the thing that goes into G, right? Okay, so you start with something. This would be like the regular price of the shoes. Then I do the first thing. I take the 25% off. Then I do the second thing. I take the $10 off of that, right? Okay, so it's one after another, and you sort of like, once you start the process, you just sort of keep following it, right? I don't like start with a value and then at some point in the middle, like jump back to that. We just sort of keep rolling. I'll give you another example in a second. F of G, or F composed with G, this is F of G. So this is F first, then G. This would be the thing on the right would be which one first? G first, then F. And again, just like the example we just looked at, order matters, right? There is almost always a difference in those two things. We'll talk more about like when there might not be, but there's sort of a special case where, you know, they're the same, but generally speaking, we want to be really careful about the order because it is important. Okay, here's another example. If we think of a function like a machine, right? We've drawn this picture a bunch, that a function takes x's and does its thing and spits out a y that goes with it, right? Composition is like doing one after another. So you put some X value in to begin with. What F does is return F of X, right? Whatever that function value is. That's what you feed into G. And then the thing that sort of comes out at the very end would be this composed value G of F of X. I think a good example that will help you kind of think through what's going on is if we do this in context of doing laundry. Not a trick question. What do you do? Close the washer, then from the washer to the dryer. Yeah, okay. So our two functions, our two machines that are doing things are a washing machine and a dryer, or, you know, clothesline or whatever. Some process by which they get, you know, cleaned and then dried. Okay. What goes into the washer in the first place? Dirty clothes. Dirty clothes in the washer. You turn the washer on. The washer does its thing. Then what? Clean clothes, but they're wet. Clean, wet clothes go from the washer into the dryer, turn the dryer on, dryer does its thing, then you turn it back on for 5 minutes, several hundred times to avoid having to get things out and fold them, right? But eventually, right? Clean, but now they are dry. And that's sort of our like finished product. That's where we wanted to end up, right? I don't know why I put an R at the end of the word close there. It's weird. Is the order important? Why don't you do those the other way around? Stuff gets weird, right? Yeah, okay. I mean, they end up clean, but that middle step where you took all your dirty clothes and threw them in a dryer for a while and just got them hot also, that's unpleasant, right? And then they're gonna end up wet at the end. So the order is important because if you switch the order on those, you got problems, right? I got little kids, so like everything's got food on it and the whole kind of thing. But so the order matters, right? Just like it did in our, you know, example with looking at putting the stuff on sale. Okay, so what if we have two actual functions? What if F is X plus 1 and G is 2X? If I want to find F composed with G, or F of G of X, what do we do? You plug G in where the X is in F of X, right? Again, this is the same thing as F of G, right? I'm going to write that step down just to, you know, help us kind of keep in mind where this stuff is coming from. If that helps you, then you do it too. If not, then that's fine. But the idea is always that we're going to be working sort of from the inside out. So I need to do G first, right? G is the washing machine here. So what we know about G is that it can also be written, it is the same as what here? 2X. Okay, so this is F of what? 2X. This is what, you know, now we see that what Emily said a second ago about like, okay, you take whatever G is, well, G is 2X, you replace that into the other function, into F, right? Because the way you read function notation is this thing is just a placeholder right? So anywhere that X shows up, I just replace it with whatever's here. So anywhere X shows up in the definition of F, I'm just going to replace it with what? One more time? 2X. And then if we can simplify anything, we do. So 2X plus 1. So what we just did is similar to what we talked about last time with, we're defining a new function, right? We're defining a new thing. We're calling it, last time we were talking about like F plus G, right? We call it F plus G because we take F and we take G and we add them together. We call this F of G or F composed with G because we take F and G and we sort of combine them in this particular way, doing composition. So we built a new function, and what that function does is sort of both of the things that they did originally, right? So it's like I took this thing where we had two separate machines, right? And to match our example, this would be F, G, and this would be F. What we just did in building this composed thing is make a thing that goes straight from there to there. That's F composed with G. Right, so I just built a new function that does both those jobs in that order. Right, so it's a combo washer dryer, I guess. Just put stuff in, it started, does its thing. That kind of makes sense? Okay, all right, so flip over to the back of the notes. The top there are 4 examples. A couple of them are having you do things with just an X, so similar to what we just did. Then there are a couple where you're doing it with a number. And then look at example 8, you're doing the same stuff, but from a graph, right? So think through, similar to that one on the front where we did stuff from a graph. You don't need to figure out what those equations are. You just need to look up the values and sort of plug them in kind of the right way. So I'm gonna give you, I don't know, 15 minutes or something to kind of work and talk amongst yourselves about things, and then we'll hit a couple of those in a minute here. Yeah, it's not really canceling, it's just that think of it more like replacing, but this is the right idea. You want to replace this X with this, and that's what you're doing. Yeah. Right, well, yeah, because what F does is take a thing and multiply it by 2. Right, so if you want F of X plus 7, that should be this multiplied by 2. Yeah. Yeah. Yeah, so same idea, just take this and anywhere that X shows up, you replace it with this, right? So you have this short on top. Okay. So x is 2x, that's 5, that's 5, that's yes, x plus 7 again. Yeah. Something like this, in place of x here, this squared minus 5. That's the whole thing. Yeah. Okay, so what you're doing, it's like you're replacing this with this, right? And then you got to replace them on both sides. So all of that squared on top. Yeah, work out what that is. Yeah. Is it okay? So. Yeah. Yep. Good. Yeah, so you can do it either way. Like you can do the same thing you've done on the previous two and like figure out what to do with X. That frankly like the laundry thing. That's like building one machine that does some things, right? Or because all it wants you to do is figure out what happens to be free, right? So it's like, okay, well, you need to do one load, right? Well, I might just choose the two machines I have. So that would be plugging 3 in here, which gives you 5, I guess, and then take 5 and plug into that. Does that make sense? Both things will get you the same answer, right? Just one is a little bit more. Is that right? Okay, there's actually kind of less to do, or at least it's not quite as bad. It's doing it with just a number instead of like a simple way. So, yeah, so 3, and the first thing you want to do is that plug it in. Yeah, and then once you get that, take that out of that. Yeah, like something like that. Well, like this, yeah, but here you should be 3 times. Well, the next spot, right? All you're doing now is 25 into plus 1. 45 minutes less extra class. All right, let's just hit a couple of these real quick. You know, remember solutions are all in Blackboard, but somebody tell me about setting up number 5. We want G of F or again, G of F of X if you want to write it that way. So what's F? 7x plus 1. So we are looking for G of 7x plus 1. Which means that wherever an x shows up in the equation that defines G, I'm going to replace it with 7x plus 1. Right? What does that look like? 7x plus 1. Right? I mean, this is G. G is things squared minus 5. Right? That's what, you know, G of x being x squared minus 5. That's what that really means. It's things squared minus 5. Okay, well, the thing that we're replacing that with is 7x plus 1. So it's 7x plus 1. As, you know, treating it as like a single piece, right? A quantity. 7x plus 1 squared minus 5. Okay, what do we do to simplify that? Expand that square. 7x plus 1 times itself, which is 49x squared plus 14x plus 1 minus 5, right? 7x times itself gives you 49x squared. 7x times 1 twice for the outer and inner parts of the product, and then 1 times 1. And then like terms, would be that. Are we all right with that? Any questions? Do we all agree? Okay. All right. So what about doing this for my graph? Here's F, this line, kind of bolder or darker on your copy, and G, this weird wavy function that's kind of grayish that we've never seen before. Okay, but that's okay, because again, all we need to do is look things up from the graph. I don't need to be able to figure out what the equation is for these things. I just need to look it up from a graph. How would I figure out what, like part A, F of G of 2 is? Find G of 2 first. Right, the inside thing happens first. So first I need to look up G of 2. Okay, we need to look up g of 2. So find the x value 2 and then find g, right? When x is 2, g passes through the point 2, -2. So g of 2 is -2. Okay, g of 2 is -2. Now what do we do? Find f of -2, right? So -2, that's our wet clothes that need to go into the dryer. The dryer is f, the function that's, sort of the outer part, the second thing. So I've got a new x value to plug in. I need to go look up -2. Here it is. And then I need to find f. F passes through -2, -4. So f of -2 is -4. That'd be the answer then. So what did we do? We needed to think about the order that they happen in, right? Again, work inside out. And then it's look up a point and then go look up another point, right? So it's just the same idea of evaluating a function from a graph that we've been doing for a couple of weeks now. We're just doing it twice, one after the other, right? And the first evaluation, the first lookup tells you where to go to look for the second one, right? So somebody walk me through. I've covered up B, so part C, G of F of 4. Jack, which function are we going to do first? F, right? The inside thing happens first. Okay, so G of F of 4. When X is 4, what is F? Two. Okay. Now, like one way you can think about what's happening is like at this point, we're just sort of starting over, right? It's like, okay, now I'm going to do a whole nother, second problem, but I'm going to start fresh. Now I'm looking at the function g, and the x value I need to use is 2. So when x is 2, what's g? Oh, -2. Right, that point right there, 2, -2. I want the y value. Okay. Do we have any questions? I think the middle one, g of 0. So you're just doing the same thing. You're just using g both times, right? It's not any different. Everything that we've done so far is either f of g or g of f, but g of g is do the same thing. You just use the same function both times. Okay. Questions about things? All right, take a look at that last problem then. So these ideas that we've been talking about, we can use them to model things as well. So now we're kind of talking about like all of it all together. So arithmetic, addition, subtraction, multiplication, division, and composition, kind of all together. Those are all tools that we have. Read that real quick a couple of times. Okay, so this bike shop has weekly profits that can be modeled by the function P of X is 150X minus 750, where X is the number of bikes sold during that week. Okay, so we're just looking at 1 week at a time, right? So, just sort of, that's our like frame of reference. We're just looking at what happens, last week or whatever. We know how many bikes were sold that week. We have this function that tells us the profit. What's profit? How much money you made, right? Similarly, their weekly revenue or total income can be modeled by the function R of X is 250X. Again, X is number of bikes that they sold. What's revenue? What's the difference between profit and revenue?
How much you sell for?
Kind of the right track. Revenue is total of what you brought in, right? So revenue is like, you're running the lemonade stand. Revenue is how much money you have in the shoebox at the end of the day, right? That's the total take that's in the till. The difference in that and profit is profit's how much you made once you take out your costs, right? So the lemonade stand again, mom gave you $10 to go buy lemons and whatever, right? You brought in $30 that day. Well, you still got to pay mom back, right? So that's the difference between profit and revenue. What we want to do is find C, a function that models the weekly costs, which are the expenses, right? Okay, we know profit, we know revenue. Cost is sort of the third part of this like triangle of things. Think about how it factors in, how it relates to those. Then once we have them, we're doing some evaluations. Find C of 10, find P of 2. What do these things represent? All right, so take a couple of minutes and try to think through, especially part A there, finding a function that tells you the weekly costs if you know profit and you know revenue. I was going to chase something I heard over there. McKinley, you just said revenue is going to be the biggest number. What do you mean? Revenue is total of what you made, during the day, right? So that's how much money's in the till at the end of the day.
So, like, that's gonna be the margin that we have, and then the profit's gonna be a portion of that.
Uh-huh. Yeah, exactly. So assuming that, like you did okay that day, right? And then you're not going to end up in the red, then revenue should be the biggest number, right? If you made money today, then revenue is the biggest number there. And you said profit's going to be a portion of that, right? What's the other portion? The other portion's the cost, right? The other portion's you got the revenue, the total take for the day. You still got to take out, your bills and wages for people and like whatever else, right? So this bike shop, they, brought in say $1,000 that day, but it cost them $200 for bikes, and they got to pay this guy $100 in wages and whatever. What's left over, that's the profit. Okay, so what are we doing when we take a number and take a portion of it out and see what's left over. Subtraction, right? Okay, what do we need to subtract? Profit from revenue, yeah. Cost is revenue minus profit. That's an equation, so you can rearrange things, any way you need to. If I had profit and cost and needed to find revenue, well, I would add this over, right? So cost plus profit gets revenue, or revenue is, profit is whatever that is, revenue minus cost, I guess. You can rearrange stuff if you need to. What do we have here? What do we know going in? We've got the profit and we've got the revenue. So if I want to find cost, we're talking about revenue. Well, I have a function for that. Minus profit, I know that one too. So this is kind of the way I would want those things to be arranged, right? If I knew two of, a different two of them, I might want to move things around. So this function c of x that we're looking for is revenue minus profit, right? Because we actually know how to write revenue and we know how to write the profit. We can actually find that function then. $250x minus 150x minus a negative, so plus 750. There you go. That's your cost function. Total weekly cost. That's how much you spent, right? That's what you have to take out to pay bills and pay for supplies and wages and whatever else, right? That's money going out if I'm in the shop. Now, again, assuming that that number is smaller than the other numbers, we're still okay, right? If that number is bigger than the others, then we're losing money. But assuming that that's smaller than the others, then we're in good shape. B asks you to find C of 10. What do? Plug in 10 here. What are you going to get when you plug in 10 here? It's not that number, but what's it going to tell you? The cost, your expenses, when you, are we making or selling, or I don't remember, sold. Your cost, your expenses, when you sell 10 bikes during the week, right? C asks you for P of 2. Well, that's again plugging in, right? Plug 2 into the function P. And what that's going to tell you is, well, 2 is a number of bikes again, right? So it's going to tell you what your profit is if you only sold 2 bikes that week. If it's positive, you made money. If it's negative, you lost money, right? Because that's how profit works. And then D asks you how much you need to sell in a week in order to break even. And what you think about that one. All right, so finish that for tomorrow. We will pick up there. Yeah, give me a second.